So in this video we will compare conditionals in Maya and Houdini or conditional statements in Maya and Houdini. So let's create a sphere in Houdini. We will set rows and columns to 50 or subdivisions in Maya. Create a sphere in Maya and we will set subdivisions to 50 as well. So subdivisions axis 5 and subdivisions height 50 as well. So let's add the attribute wrangle node in Houdini. Attribute wrangle. So let's connect it with the sphere node. So here we will write our expressions. So it's like script editor in Maya or expression editor. So if you'll go to translate X, highlight translate X, and we'll go to edit, and we'll choose expression editor. So in the expression editor we'll create our first expression. So we can copy selected object and attribute. So let's paste into the expression field. So 2 slashes is like comment, so we might not worry about mistakes when we create an expression. Expression might be simple and might be complicated, but the basic principle looks like this. So if we say that our translation X is bigger than 3, or more than 3. Let's just say in Y, because we have the green axis, we will move in the Y axis, we will move up. So we will move our sphere up. So if translate Y is bigger than 3, then we will have, it will be in the close parenthesis. So if our sphere 1 is going up in Y higher than 3, then we will have the result. So it will be our condition in the brackets, and the result will be in the curled brackets. So if the sphere is moving in the Y, then we have the result of our condition. So then in the curled brackets something will happen. So we might change any attribute as a result. So before we will create a boolean. So that's the boolean 1 material. And to see our boolean material, we need to open our hypershade editor. In the hypershade editor, we will select our boolean 1 material, and then it appears in the expression editor. So now we have all the attributes of that boolean material. So we might add any attribute and write expressions. So let's copy color R. So that's boolean 1 color R. That's the color in the R channel. We will see how our attributes look. So let's choose by expression name, So we see that we lost our expression because we didn't press edit button. So now we need to rewrite our expression. So if something happens, if p sphere 1 in translate y is higher than 3, then our blend 1 color in the R channel will be equal to 0.1. So, and then, so when our sphere reaches the value of 3, the color will be changed. So if it's higher than 3, then it will be changed. So let's press edit. To see better, we might just uncheck selection highlight. So we just uncheck selection highlighting. So we will see our sphere without the wireframe. So we see if you go back, our expression is not refreshed when we are moving our sphere. Like the color remains the same. So if we move our sphere lower than 3, the color is the same. So we need to write another part of our expression. So if your sphere in the y-axis is higher than 3, then we have our color so and so, or else our color will be set to the previous position, to the previous color. So we say in the curly brackets we write blend 1 color R is equal. So we need to write blend 1 because we might write. So of course we might even rename our blend color, so it might be any word. So we will just set to 0.5, and we end our expression with the semicolon. So if something happens here, then we have here or else, we have this. So if it's higher than 3, we have 1 color. If it's lower than 3, we have the gray color, the previous color. Or if we will logically continue our expression, we might say, or we'll write, if our p-sphere 1 in the y-axis is translating or moving lower than -3 in the y-axis. Close with the parentheses. If our sphere is moving lower than -3, then in the curly brackets we have the result. So we write our blend 1 color in the R channel. Will be just 1, for example. So we will have the red color. So let's press edit. So if it's lower, then the blend color will be getting red. So I'm used to 1, so that's the mistake. we have the red highlighting in the lower right corner of the program. So we have this error. When we are moving our sphere, it doesn't work. Yeah. So if we correct our mistake, then press edit, we see that our expression is working when we are moving the sphere. So that's the condition in Maya. So let's write the same expression in Houdini. Let's go back to Houdini. As we said before, we need to write our expression in the Vex expression field. We might press Alt E to have the separate window for our expressions. So it's called Edit String 4. It's like script editor or expression editor in Maya. So it's just like Notepad for coding. So the hotkey is Alt E. So in Houdini we will write the following code. So if you say if our points, the position of our points in the y-axis is higher than 3, you write the percent and then the p in point y. So it's higher than 3, then in the curly brackets, so we have the same curly brackets. So in the curly brackets we have the result of our condition. Then we have the result of our condition. Then we write our color will be set, I'll call CD will be set, or it's equal to the channel, to the color. So you write like 3 values. So we have our channel in 3 channels. We write 0, 0 and 1. So let's apply and accept. Let's move our sphere. Let's move in the center. Let's move the center in Y. In the Y-axis, or select the center in Y and move it and change the value. So we see that our points are changing. We have points and we might change to detail only once. Then we will have the color changed at once like in Maya. So it will be changed at once on the whole object. So if you would like to appear our color points by points, then we'll need to set 2 points. Point 1, 0, 0, 1. So if it's higher than 3, it's blue, and if it's so to go back like in Maya, so to continue our expression, we write else if, we should write else if, so we write else if, so else if the position in Y is lower than -3. So the value is less than -3. We close our parentheses. Then we have the result. So we have the result. In the curly brackets we write the result. Then it will be getting. So then our color, CD color or CD attribute set to another color, to a different color. It will be just, we might write like 100. So if our sphere is higher than 3 in Y, then our color is getting blue, and if it's lower than 3, it's gray. Then it's gray if it's lower than 3, and if it's lower than -3, it's getting red. From blue to gray and to red. So basically that's the same like in Maya. Let's put our programs side by side and place the windows of our program side by side. So let's minimize or maximize the window. So we'll be moving in the Y. So it might be X, it might be Z, any. So we see that the color of our sphere in Maya is not exactly the same. So we are talking about maximum similarity. So let's quickly render. Let's go to Maya software to render quickly. So let's just see. So in the render view we will see. So we see that's the blue color, and not really like. So if you press render, let's go back to the scene view, position our sphere, and let's render back. Just press render. So we need to tweak our code in Maya slightly to have like the saturated color. It's not that bleak color. So we have like the dark blue color. So in Maya, if you would like to have the same color with the same saturation, we will change our expression slightly. So let's just check selection highlighting. Let's go to Windows and then to animation editors and expression, the expression editor. And here we have our expression. So we need to change our color not only in the R channel but also in the green and in the blue channels. So we write blin1 color G is equal to 0. So the G channel is equal to 0 and semicolon, right? Semicolon. And the blin1 and then we write blin1 color B, blend 1 color B, that's a blue channel, will be set to 0 as well, will be equal to 0. Else, in the else part we write also so we need to set the green and the blue channels. So let's just copy blend 1 color, Control C, copy, and Control V and paste. So and write blend 1 color G, so blend 1 in the color R channel and the blend 1 in the green channel is 0.5 and in the blue channel is 0.5. So then the last color, when our sphere is moving lower than -3. So for the R channel we write 0, and for the G channel, we will have, so we'll have 0 as well for the green channel, and for the blue channel, we'll write 0.5 and end with the semicolon. So let's press edit. So and it's written accurately and neatly. So now we have like the exact similarity. So we'll just uncheck selection highlighting. And then we see our colors changing. And they look exactly the same. So we have the same result like in Houdini. So let's put our windows side by side. So let's just zoom in. Let's just render quickly with the Maya software. Let's move higher. So now we have, so it's not perfectly the same because let's go to the expression and let's go back to the Windows animation editors and the expression editor. We will change our colors, our values. So let's change to 0. Let's change like 005. R0 and G0 and blue 0.5. So the last color will look like this. So when it's lower than -3. So we write. So then the last color. So in the R channel we have 0, and in the green channel we have 0 as well, and in the blue channel we have 0.5. So when we render our sphere, you see it's like blue, so like the same like in Houdini. So we have the same in Houdini and Maya. Okay. So now we have like the same similarity, the exact similarity. So we have the same colors, we have the same similarity. So let's just move our sphere and check. So we move our sphere in Houdini. it's red, and then we move it's gray, and then it's blue. So if we will be lazy enough, we might add a small piece of code to animate our sphere. So let's go to animation editor and expression editor, and we will write pSphere1 translate y, and we will make it equal to time, for example. And say that in the parentheses, and now let's see what we'll get. Edit. So now it's working, but it's working only in the positive direction, in the positive y, so we might add the sine function. So it's working, but the amplitude is not very high, so we'll multiply by 8. So now it's working. So now we have it changing the color. So we might do the same in Houdini. We'll write our position attribute in y. So it's py will be equal to time. We should write that with the %, that the time attribute, and then the semicolon in the end. So we just play and see our sphere is like squashed. So because we need to write, we should write the plus before the equal sign. I just play it again. So it's working, but it's just, but again it's very slow, like in Maya, and it's only in the positive y direction. So we will add the sine function as well. We'll add the sine function as well. The amplitude is very low, not high enough, so we'll multiply by 8 as well. So now we have the same. So if you're lazy, we will write that piece of code not to move our sphere manually. It's just the playback speed, just the playback speed differs here. So we will remember that we need to write the same speed and the same number of frames to have the same animation after rendering, and the same parameters in Maya and Houdini. So if we render our spheres, so render it in Maya and render in Houdini, and render, let's place it lower and render. So the similarity and the conditional statements in Maya and Houdini. Like if you would like to have like the same So if it's the same look like materials and the lighting, the same lighting conditions, so we see that the color is just, eccentricity is different. Thanks for watching.